Coming to the 5b question, we have the function from the relations, and the function is defined as 3x minus 5 for x is greater than 0 and minus 3x plus 1 for x is less than or equal to 0. Our task is to determine f of 0 and f of 5 by 3. Okay, so f of 0 will lie in this domain and f of 5 by 3 will lie in this domain. Okay, f of 0 will be minus 3x plus 1. Instead of x we have 0 here, so the answer will be 1, and f of 5 by 3 is 3x minus 5. Okay, so when we apply this 5 by 3 here, we'll get the answer as 0. The second part of the question is to find f inverse of the interval minus 5 to 5. Okay, now what does the interval minus 5 to 5 mean? From minus 5 to 5, in between f of x should lie. Okay, so f of x, we have two cases. First one is if x is greater than 0, f of x will be 3x minus 5. Okay, so minus 5 less than or equal to 3x minus 5 less than or equal to 5. Okay, now we have to find out the value of x here. How will we do that? See here, it's minus 5, right? So we'll add 5 in all these equations, so the minus 5 will be eliminated here, and here we'll get 10, and now we'll divide by 3 because we need just x here, so we'll have this equation here, 0 less than or equal to x, and which is less than or equal to 10 by 3. Now for the second one, when x is less than or equal to 0, the equation is minus 3x plus 1. Okay, so minus 5, then less than or equal to minus 3x plus 1 less than or equal to 5. Now we have to eliminate this 1 from here, so we'll add minus 1 throughout and we'll obtain this, then we'll divide by minus 3, then we'll obtain only x in the equation. So x is in between minus 4 by 3 and 2. Okay, so the interval will be between minus 4 by 3 and 2, or 0 and 10 by 3. So the overall interval is x lies between minus 4 by 3 and 10 by 3. The next question is from the composition of functions. So we are given with three functions f, g and h, and which is from z to z, defined by f of x, g of x and h of x. Okay, so we need to verify f of g of h is equal to f of g of h of x. Okay, so we will consider both cases now. See here, considering first one, f of g of h of x. Okay, so f will be outside and g of h of x will be calculated first, which is what is g of h of x? See, g of x is 3x, right? So instead of x it is h of x, so it will be 3 times h of x. That's what we have written here, 3 of h of x. Now f of 3 of h of x, what is f of x? F of x is equal to x minus 1, right? So if it is 3h of x, it will be 3h of x minus 1. F of g of h of x. Okay, so what is f of g? F of g, f of g is 3hx minus 1. Again we get the same thing, which is minus 1 and 2, and by that we can prove that f of g of h is equal to f of g of h. Okay, coming to the sixth question, we have been given with the set A 1 2 3 4 6 and R be the relation on A if, defined by A relation B if and only if A is a multiple of B. Okay, so we are gonna select two elements from this which satisfy this condition, which is A is a multiple of B. Okay, so what we need to do first, we need to find the pairs, and after that we need to represent the relation as a matrix and draw its digraph. So the relation is defined as A comma B if and only if A is a multiple of B. In each of these cases you can see the first one is A and the second one is B. Okay, so A is a multiple of B in each case. Okay, so in that way we will select all these elements from among the 5 elements given to us in the set A, and after that we will create a adjacency, we will create a matrix. Okay, in this matrix we will represent all these elements which are given to us in the row and the column, and if there is a relation between two elements, between that two elements we will write 1. If there is no relation, like between 1 and 2 there is no relation, so we will write 0 there. After getting done with this, we will move on to the digraph. In digraph you will mention all these elements which you have, and if there is a relation between any of the two elements we will represent it with the arrow. Okay, and each element has self loop also. Okay, Self loop means if the self loop of 6 represents 6 comma 6, 6 comma 6 belongs to R, so it will be shown by self loop. The next question is to draw the Hasse diagram of representing the positive divisors of 36. So firstly we will be writing the set which are all the positive divisors of 36, and then we will find the relation R, which is defined as A or B if and only if A divides B. Okay, so it's a partial order on this set. We note that under R, 1 is related to all the elements of S. Okay, see, it's a partial order. Partial order means that the relation R should be reflexive, okay, reflexive, antisymmetric and transitive. Okay, if these three conditions are satisfied on the relation, then it's a partial order. After knowing that it's a partial order, what we have to do? We have to find out the elements which are related. Okay, so since there are many elements, we have to write in this way, and we'll get the relations between the elements, and after that we'll make the Hasse diagram. Okay, see, Hasse diagram is made in this way. The least element is written here, the next two greatest elements will be written, and the relation will be made here. I have explained in the theory part of this DMS module 3 video how to make the Hasse diagram. The next question, we have been given with a set and defined a relation R by A cross A, x1 y1 relation with x2 y2 if and only if x1 plus y1 is equal to x2 plus y2. Now we have been asked to find out two things: verify that R is an equivalence relation and find the partition of A cross A induced by R. Okay, now for the equivalence relation we need to prove three things, which is reflexive, symmetric and transitive. So for any x comma y belonging to A cross A, we have x plus y is equal to x plus y. So x comma y relation with x comma y belongs to R, so R is reflexive. Similarly, symmetric means x1 plus y1 is equal to x2 plus y2. Okay, so x2 plus y2 is also equal to x1 plus y1. Therefore x2 comma y2 relation x1 comma y1 also exists, therefore the relation is symmetric. Now for transitive we will take three elements, which is x1 y1, x2 y2 and x3 y3. The first two are in a relation and the second and the third one are in a relation. Okay, now x1 plus y1 is equal to x2 plus y2 and x2 plus y2 is equal to x2 plus x3 plus y3. Now by these two equations, what we can write, x1 plus y1 is equal to x3 plus y3. Therefore x1 comma y1 is in relation with x2 comma x3 comma y3. It's actually x3 comma y3. Okay, therefore R is transitive, and since we have proved that it's reflexive, symmetric and transitive, therefore R is an equivalence relation. Now our next question is to determine the partition induced by R. Okay, we have to consider each element here, which is 1 comma 1. Okay, now see, when we have written the whole relation, 1 comma 1 is related to none but only 1 comma 1, so only one relation will be there in this set. Then 1 comma 2 is related with 1 comma 2 and 2 comma 1. Okay, so that's the partition set of 2 comma 1 and 1 comma 2. Now for the third one, 1 comma 3 and 3 comma 1 and 2 comma 2. Why? Because 1 plus 3 is equal to 3 plus 1 is equal to 2 plus 2. So the equivalence classes for all of these will be the same thing. Okay, and the set will have these three elements in it. Similarly we have for the other elements also. So after that what we have to do, we have to consider those elements in which all the elements are included. Okay, means the equivalence classes, we have to select those equivalence classes which have the distinct elements. Okay, so in the partition what will include, see, we can include any of the classes, just that all of these elements should have the distinct elements. Okay, and all the elements should be covered by these classes. Okay, so we will select those classes and we will make a union here, and that's the set which we need to write in the final answer. Moving on to the module 4, we have the first question. So number of ways of placing 8 letters is 8 factorial, and number of ways of placing 8 letters in 8 envelopes such that no letter is in the right envelope is D8. Okay, D8 is 8 factorial into e raised to minus 1. So see here, the number of ways of placing 8 letters in 8 envelopes such that at least one letter reaches the right person. Okay, the subtraction of these both gives us the required answer. Okay, firstly we will write the total number of permutations of 26 letters, which is 26 factorial, and then we have A1, A2, A3 and A4, which represent car, dog, pun and bite. Okay, now see, A1 means how many permutations have the letter car in it. Okay, have the word car in it. Now when we remove 3 letters from 26, we will be remaining with 23 letters, and if you consider this as one letter, so the total number of letters will be 24. So A is 24 factorial. Similarly for dog also and for pun also. Now bite has 4 letters, so it will be 23 factorial. Similarly we have the intersection of both means A1 and A2, which means if car and dog both are removed, we will be remaining with 20 letters, and since this is considered as one letter and this is considered as one letter, so we will add 2 more letters with 20, so the total answer gives us 22. Similarly for this one and this one, and after that we have 3 letters together. Okay, like a car, dog and pun together, so it will be 17, the same thing as the previous one, 17 plus 3 which is 20, so we will have 20 factorial. Similarly for other combinations also, and then we have the 4 letters together. Okay, in that we will get the total number of ways as 17 factorial. Now according to the formula, what we need is A1 union A2 union A3 and union A4 bar, because all of these letters should not occur in any of the patterns, so the bar is used here, and that is equal to, according to the formula, it's A1 bar intersection A2 bar intersection A3 bar intersection A4 bar. Now we will apply all these values which I had found here. The expansion of this formula is this one, that is S, which we had found out earlier. See, this is S, okay, which is 26 factorial. We have to write that minus this one. This is nothing but the, see here, 3 into 24 factorial plus 23 factorial. Now this one is the sum of these 3. Now 3 into 24 factorial plus 23 factorial. Then we will use minus sum of all of these. Okay, then again plus sum of these, then minus this one, 17 factorial. That's the formula. Okay, so we'll have here 26 minus this plus 3 taken together minus 4 taken together. Okay, observe here carefully, this is the given board. This board is divided into 2 parts, which is D and E, and I have made a star here which denotes that 2, 4, 5, 7 and 8, which is the D, and E means we are just removing this one and the remaining thing is written in E. Now after that, for each of this board we will find the root polynomial and finally merge it together. Now see, for the board D you have to find out R1, R2, R3 and R4 or R5 till how much it goes. Okay, now let's see how to find that. R1 is always the number of elements in it, which is 5 elements, so R1 is 5. So next R2 we have to find. R2 means considering 2 elements at the same time. I have explained this in more detail in the theory explanation video, you can refer to that, but now I will be just going through very briefly. Okay, so in that we will find R2, similarly R4 and R5. In this case all these 3 are 0, and we will find Rdx. Rdx is 1 plus 5x plus 4x square. Then for the board E also is the same thing. We will find out R1, R2, then R3, then R4 till R7 it's 0. Okay, then we will find Re of x. Then the way we merge is x into Rdx plus Rex. Okay, so we will get the final answer here after the expansion. This is the 8th question. An apple, a banana and a mango and an orange are to be distributed among 4 boys, B1 to B4. The boys, see, 2 boys do not wish to have an apple and those conditions are given, and in how many ways the distribution can be made so that no boy is displeased. I've explained this in theory part as well, so if you want to go in more detail about it, you can watch that video. See, first we'll take the rows as the columns as b1 to b4 and the rows as the fruits names, okay, and then what are the conditions given, that conditions will be highlighted here, okay, and then we'll form a root polynomial. See, first we'll get the board, the shaded parts will be taken and we'll form a board, first part, second part and third part. So C1, C2 and C3. Then we will write RC of x as RC1x into RC2x into RC3x, okay. Then for each board we will find R1, R2, those values, and we will find the RC1x. Similarly, we will do for RC2x and RC3x. We will find the equation. At last, we will multiply all of that. Okay. We have to find out the values of R1, R2, and R3 from RCX. Okay. So after finding R1, R2, and R3, we will have to find S0 to S3 using these R1, R2, and R3 values. This will be getting the answer here. Then n is the number of ways which is given by this formula, and the answers we have got here, we will be just substituting all of these answers here to get the final answer, which is 6 ways of distributing fruits so that no one is displeased. The next question is regarding the recurrence relation. We have been given with 4 values, a0 to a4, and the relation given here is this, and we have to find out the constants b and c and solve the relation. Okay, first we need to find out the constants. See, now first we will write the constants here which are given here, and then by using this equation we will find out the values of b and c. Okay, now for n is equal to 0, when n is 0, a n plus 2 is a2, b a n plus 1 is b a1, and c a n is c a0. Okay, so then we will simplify it by using the values which you have here. A2 value we know, and a0 value also we know, a1 also we know, so b will get as minus 4. Similarly, if we put n is equal to 1, for n is equal to 2, we will get another equation here. By equation 1 and 2, we can find the values of b and c. C we will get as 27 by 8, so we have b and c constants here now. Now we will be applying these constants in the given equation. Okay, it's 1 a n plus 2 plus b a n plus 1 plus c a n. This is what the question was given to us. See here, a n plus 2 plus b a n plus 1 plus c a n, that's equal to 0. See, the constant will be here only a n plus 2, a n plus 1, a n. These will be replaced by k square, k and 1. Okay, k1 and k2. Okay, so we will get the roots k1 and k2, and see, they are distinct and real, right? So we have the formula for distinct and real roots, which is a n is equal to a into k1 raised to n plus b into k2 raised to n. Okay, this is the standard formula for real and distinct roots. Now by using this formula, we will substitute the value of k1 and k2. We will substitute the value of n here as 0, and then we will find one equation. Similarly, we will do for a is equal to 1 also, and we will get another equation which is this. Now by using these both equation, what we do is we will find out the values of a and b. So once we find out the values of a and b, what we do is we will substitute the values of a and b in the equation, this equation will substitute the values of a and b. K1 and k2 is already known, so we will substitute that as well. This is the final answer. The next question is, how many integers between 1 and 300 are divisible by at least one of 5, 6, 8, and the second part is divisible by none of 5, 6, 8. First of all, we will write s, which is the total number of numbers here, which is 300, and abc be the number of integers divisible by 5, 6 and 8. Okay, so what is a? A is the number of integers divisible by 5. so the total number will be 300 by 5. Similarly for B we have divisible by 6, which is 300 by 6. Third 300 by 8. Okay, so these numbers are for A, B and C alone. Then what we will do is we will consider both of these together, which is divisible by 5 and 6. So 5 6 is 30, 300 by 30, which is 10. We are just taking the LCM of this here. Okay, and B and C will get 24, and then we have 3 numbers at a time. So the LCM of those 3 numbers is 120. So 300 by 120 is 2. Then the equation is S1 is equal to A plus B plus C. S2 is equal to A and B plus B and C plus C and A. We had found out earlier, right, these terms. So we will just substitute these values and find out the answer here. Okay, and S3 is all 3 together, which is 2. Now after doing this, we have to find out how many of these are divisible by at least one of this. Okay, if it is at least, you will use L1. Use the formula to find the answer here, and number of integers divisible by none of 5 6 8. Okay, that means none of 5 6 8 means A bar intersection B bar intersection C bar. Okay, so that has this formula, total set minus S1 plus S2 minus S3. We will just substitute the values of S here and find the answer here. The next one is to find that the two graphs are isomorphic. Okay, so in isomorphism what we have to do, see, for isomorphism you need to get a bit more imaginative, because in your mind you have to correspond this figure with this figure. Okay, so in this image you can see that, see, this one, if it is taken up here, and this one if it is taken down here, you will be with this image, right? See here, u1 is with v1, so u1 and v1, u5 is with v2, so u2 and v5, and u2 and v5, u3 and v4. This one is brought down and this one is brought up. Okay, so in if you do that, the figure will look like this. Okay, so after getting over with the vertices, we have to find out the isomorphic edges. Okay, now in edges what we have, see here, after knowing which, see, u1 is correspondent with v1, u5 is correspondent with v2, so between v1 and v2 there is an edge, right, which is between u1 and u5. So we will write here u1 comma u5 is correspondent with v1 comma v2. Okay, this edge and this edge. Similarly we will write for all other edges also, and then if all the edges satisfy the condition and the vertices also satisfy the condition of correspondence, then we can write there exists one-to-one correspondence between vertices and edges, therefore the two graphs are isomorphic. The second question is to define the following: simple graph, subgraph, complement and spanning subgraph. The first one, simple graph, a normal graph and which does not contain any loops and multiple edges. Okay, that's a simple graph. The second one, subgraph. In subgraph you will have a graph here, and if you take out a part of this graph separately, this graph is known as subgraph. And the third one, see here, if this is the graph here and the complement is defined as the edges which are not present in this, so the edges which is not present in this is dB, so that will be shown here, and this is the complement of this graph. The fourth one is spanning subgraph. Consider a main graph here, and in this graph we have 4 vertices, which is A, B, C and D. Now in spanning subgraph all these vertices should be there in the subgraph, but this is not a spanning subgraph because A is not present. The next question is to construct an optimal prefix code for the symbols AOQ, UYZ that occurs with the frequencies which are given here respectively. Okay, now first step is to write all these letters with their frequencies, and then arrange in an increasing order. Okay, means the least to the highest. When we arrange in this form, what we have to do, the first step is take the least 2, which is 4 and 7 in this case. So we will merge it together and add these numbers 4 and 7. So V1 will be 11. Then again consider the least 2 numbers, which is in this case 11 and 12. So we will merge 11 and 12 together and write here as 23. So the next two least numbers are U and A with 17 and 20. We will merge it together and write V3. Similarly, we will keep on doing until we obtain this tree here. And then what we have to do, remember, if this is the node and these are the branches, the right part will be 1, left part will be 0. In this case again left part will be 0, right part will be 1. Okay, so in that case we will write here zeros and ones, and after that we have the code for each of these numbers. So we have code for each of these letters. Consider for example U. U is here. To reach U, you need to pass from 0 again 0. So U is 0 0. A is here. To reach A, you will go first 0 then 1. So A's code is 0 1. So the letters are these and the prefix codes are these. The first part of the question in the question number 10 is to prove that two simple graphs G1 and G2 are isomorphic if and only if their complements are also isomorphic. Okay. Now, if you remember, the complement is the edges which are not present in the main graph, that is the complement. So the complement of this is AC and the complement of this is HF. Okay. So we have to prove that if these both are isomorphic, then these graphs are also isomorphic. Let's see how to do that. First we will prove the isomorphism for these two graphs. Okay. Now see, A is correspondent with F. Okay. Then if you consider C and H also to be the same, then the diagonal which is AC here and the diagonal HF is equally correspondent with AC. So there exists one-to-one correspondence between the vertices and the edges. So therefore the two graphs are isomorphic. If the two graphs are isomorphic and they are the complements, then the original graphs are also isomorphic. Why is this so? It's because, see here, what are complements? Complements are nothing but the edges present in a graph are not in the complement and vice versa. So suppose that these are the two figures. If the missing edges have the isomorphism, see, this is the missing edge here and this is the missing edge here. Okay, so if these two are isomorphic, then what are not missing also, they will also be obviously isomorphic. Okay, coming to the second question, which is let G is equal to V comma E, the number of vertices and edges, be a simple graph of order V is equal to N. So N is the number of vertices and E is the number of edges, which is M. If G is a bipartite graph, prove that 4M is less than or equal to N square. For a quick demonstration, a bipartite graph will have two sets and the connection will be made between the opposite sets. Okay, there will be no connection between the elements of the same set. Okay, this is not possible. So consider two sets here, and these sets have V1 vertices here and V2 vertices here. Okay, and V1 means R vertices and V2 means S vertices. Okay, and the connections will be made in between both of these. Now the total number of vertices are R plus S, because R vertices are here and S vertices are here. So total number will be R plus S, and S is equal to N minus R. N is the total number of vertices minus R, that gives S. Okay. Now the graph G has maximum number of edges when each of the R vertices of V1 is joined by an edge to the S vertices of the V2. This maximum number is equal to RS. See, if we have to connect all these edges with all the vertices here, so in that case if it's R here and S, the total number is RS. Then the total number given is, the total number of edges are M. which is less than or equal to rs. Okay, now it's just the simplification part, and we have the value of s as n minus r. Substitute the value of s as n minus r and then expand it. By completing square method, we obtain the final result, which is r is equal to n by 2. Now when r is equal to n by 2, rs is equal to n square by 4. Why? See here, while we substitute the value of r here as n by 2, this term will be cut, so the remaining term will be n by 2 whole square, which is n square by 4. So therefore m is less than or equal to rs, which is equal to n square by 4, and then cross multiplying it, we get 4m is less than or equal to n square, and that's what we needed to prove in this question. The last question is construct an optimal prefix code for the letters of the word engineering, hence deduce the code for this word. So in engineering we have 3 E's, 3 N, 2 G, 2 I and 1 R. Okay, so the frequencies will be arranged in the increasing order, and then we'll merge the least 2 together, which is 1 and 2, we'll get 3. Then the least 2 are 3 and 2, so we'll merge it together. Or we can do this also, since this is also 3 and 2, we'll merge it together. In the question it is done in this way, so we can do this as well. And then we have the least 2, which is 3 and 3, so we'll merge it together, and then we'll merge these both at the end. Okay, so we'll get the final tree as this one. Now the left part will be zeros and the right part will be 1. In that way, for each letter we will calculate the code and write the word engineering by substituting the values of each of these letters. Okay, see en, it's ENG, right? So it will be E first, 10 01 00, 10 01 00. Then again I is 111, so it's 111 here. Then it's N is 01, so it's 01 here. In that way we will write the word in this form here.